Very much, Dave. Thank you. Okay, well, thanks, ladies and gentlemen, and very good morning to everybody. Well, the title says it all, really. So, I mean, we could just go to the next talk and then have lunch, but I suppose I could better say a few words about it. What I'll do is I'll bring us up to speed with what we're doing on land seismic at the moment and tell you where I think we're going. And I'll have to do a little bit of leapfrogging between land and marine because these technologies do leapfrog each other every so often. So let me kick off in the 1920s because in the early 20s a German inventor, Ludger Mintrop, had invented a seismograph machine, and he was doing exploration work with refraction land seismic on the Gulf Coast, and made a salt dome discovery in 1924, which really kind of took the interest of all the explorationists at the time. He, of course, Mintrop, founded the German company Seismos, which became Praxis Seismos. In its day, one of the best of the seismic contractors, and therefore in due course became subsumed into the Schlumberger empire. More of that anon. Anyway, moving forward into the 40s, we go from refraction into reflection, and in the 40s we were interpreting, I shouldn't say we because I was 1 year old at the time, but anyway, we were interpreting seismic records that looked like that. Single cover, these are 8 trace records stuck together with tape at the back, and no compensation or move out or anything like that. You had to build that into your interpretation, although there were some mechanical aids later on. But that's what people were interpreting at the time to make their discoveries in places like the Gulf Coast. And moving on to 1950, a major infusion into the land technology was done by Harry Main by inventing CDP Stack, which at a single stroke enormously improved the quality of the land data, as you can see on the picture on the right-hand side. If you'd like to interpret that, that's the improved one. Harry Main was probably one of the best assets that his contractor Petroleum Geophysical had. Anyway, Petroleum, of course, via Geosource and HGS and Western, became subsumed into the Schlumberger empire. So that was the 1950s. 1952, while land seismic was doing all this, luckily Norbert Wiener at the MIT in the States was laying the foundations for our digital technology. And what it says there can't really be true, because 2 of the students from that time, Anders Robinson and Sven Trautel, went on to teach us much of what we know about digital filtering, deconvolution, and things that we sort of take for granted, which were brand new at the time. They're wonderful gentlemen. If you ever get a chance to meet them, please do so. They're terrific people. Outspoken too. I mean, I remember Sven Trautel once standing up in a big SEG meeting in the States and announcing that his management, a major oil company, couldn't even add 2 and 2. Anyway, we'll come back to that one too. 54, land seismic had a big boost again because vibrosize was invented by the Conoco company, Crawford, Doty and Lee, and quickly, as you can see on the chart on the right, captured a huge percentage of the land seismic market. In fact, that graph stops in 86, which is when SEG stopped collecting statistics. But right now, it probably has 75% or more of the land seismic market, and you would only use explosives these days if you couldn't put your vibrators in somewhere. So that's vibrosize. Of course, in the 60s, we moved very quickly through from analog into digital. It happened over about 2 or 3 years, very quick indeed. On the left, you can see one of these old analog. Actually, it was a vibrosize correlation unit for 24 channels, and on the right, you can see the sort of equivalent digital processing centers that were coming up at the time. At least 2 of you in the audience will recognize a very young Herschel Stinson on the right, who was one of my bosses at the time. There we go. What was marine doing then? Well, marine was just beginning to exist at the time, with some rather small, insufficient sized boats, really, and these would be chugging along, and the guys would be chucking the explosives out the back or off the side of the boat. And that's what was happening in the late 50s, early 60s. In fact, there's another picture. That's the SSL Christian Tonder boat, and the guys on the outrigger, of the outrigger on the left-hand side of the picture there, these guys are chucking 50-pound explosives off the side of that boat. And in those days, the boat would stop because the streamer was buoyed to the surface, and you'd hope that the explosive charge was in about the right place, and off it would go. So there we are. That was done by Seismic Service, SSL, one of the best contractors at the time, now of course subsumed into the Schlumberger empire. But marine seismic was heading for quality, heading for quantity and quality at the time. Helicopters were no strangers to the boats. Some of the boats were about the same size as the helicopters, so there were no heli decks, but they used to winch the tapes off, presumably in case there was some accident with the boats. Moving to land again, had a major boost with Exxon inventing 3D land seismic in 1967, very secretive of course, but it was commercialized first by GSI in 1972 with a collaborative research experiment in Bell Lake in the USA, on land in the US. GSI, of course, was the best seismic contractor at the time, and duly moved into HGS and Western, and then into the Schlumberger, subsumed Schlumberger empire. So that was land seismic at the time. Marine, I have to leapfrog here, marine had a major boost in 1972. Actually, airgun was invented by the Bolt Company in 66, but by about 72 it was in widespread use, mostly by GSI because they had the license agreement sewn up. So it wasn't until maybe the later 70s that most of the other contractors began to be able to use it. And it had a major effect on the efficiency of the marine operations and probably on the improvement in the fish population too. Back to GSI, because GSI also got going first with Marine 3D in 1975, using boats like the one on the left. Again, inadequate for places like the North Sea, but it worked, towing one cable. And the marine manager, you can see there, Davy Einarsson, really dynamic guy. I hadn't realized until I looked at that citation, when was it, sometime this morning, that as marine manager of GSI, he'd actually completed over 300 3D surveys before the next contractor, CGG at the time, got one in. So there we are, that's from the Canadian ACG Award citation quite recently. Okay, moving on. And in 1990, we start using multi-cables in a big way in the North Sea. People did use two cables for a couple of years successfully before that, but it was kind of a dodgy start, so I've started with three cables. The first two-cable operation, we think, was done by CGG, very secretive, in South Africa, and we think they got their cables so badly tangled together that they swore they would never ever do a multi-cable operation ever again. So that was the start of the multi-cable work. GECO did the industry's first three-cable job. In fact, it was for BP on the Clare Field 2068 in 1990. GECO, sort of North Sea, young North Sea company, did wonderful things for the quality of marine work in the North Sea at that time. Really good contractor, and of course got subsumed into Schlumberger quite quickly. So that was multi-streamer work, and by the mid-90s, the industry was towing lots of streamers in the North Sea, and it was becoming extremely efficient and very, very good, high-quality seismic, operated with tremendous speed and efficiency. Now, I kind of apologize for showing the slide because you've seen it before. I mean, I produced it in 1994 and it got waved around within 5 minutes. It made me very unpopular with contractors because, of course, it shows the cost per square kilometre on the vertical axis suddenly going down, and that's the result of these very efficient North Sea operations that the contractors were doing for us at the time. And it was unpopular, but on the other hand, at that time, we had to fight really, really hard to get the money to do a 3D survey in an oil company. And from about the time that yellow arrow starts, the mindset changed completely, and we had to we had to argue a case for not doing 3D seismic. So which side would you like to be on? So actually it was the right thing to do to produce that slide in retrospect. I'll jump to land in a minute, but just to give you a perspective on that marine work, there's the vertical axis again is the cost per square kilometre, the unit cost, and look at the marine cost compared to, as we go towards the right there, the transition zone, swamps, deserts, a bit cheaper, but not that cheap, foothills, low mountains and high mountains. So let's jump into land for a second. In there again. So, where do we go? Land, I think, at this time hits a brick wall because it's very expensive stuff. If I plot a graph of the cost per square kilometre of a collection of land surveys, they're all over the place and they're generally very expensive. But it was obvious what to do, really, because if I plot the cost per square kilometre against the slowness of the survey, the days per square kilometre, it was blind obvious that you just had to speed the surveys up. And you could get that cost way down into the, if you could do the surveys fast enough, you get that cost down to the marine level. So, what happens? Well, we had some difficult terrain in Colombia. We tried some of these autonomous land units. It's called the SGR, the Seismic Group Recorder, invented by Amoco. I mean, maybe their management couldn't add 2 and 2, but their technical departments were really, really good, world class at the time. So there's the Seismic Group Recorder, and you use a mechanical tape recorder, and you have to harvest the data every evening and charge the batteries. But my goodness, you could get these things into places without dragging cables around, and it was pretty effective. And also another thing we tried at the time was these autonomous units called OPSIs, which had a battery and a radio transmitter, and you could get your data back, but it was quite heavy on batteries. But you could put these things into difficult terrain. We used one of these in the Oman, and I remember Shell running a very successful 3D survey with them in Colombia. Ilko Sixma wrote a very good paper on that, which he gave at one of these conventions in Venezuela. So it was obvious, really, that that's the way we should go. And I did work quite hard at that. In the 90s, I wrote a paper and got a workshop going at the ACG, and I failed completely to make any impact whatsoever. So there we go. Anyway, it was a Shell guy, Justus Rosamond, working in Oman with PDO at the time, who woke us all up to the fact that our typical vibrosize operation was actually very inefficient, because looking at the diagram, the vertical axis is time, and if you're sweeping from 0 to 6 seconds, top left there, and going from 8 to 60 hertz, say, then on the second sweep further down there, then most of the area there on the time frequency chart is blank. And that offended him, obviously, and he had to think what to do with that. So there we go. He produced what's called a slip sweep, so he's just occupying some of that time frequency area with a certain amount of technical risk, but manageable. And actually that made just a huge difference to land seismic. And you can see he experimented with that on the graph on the bars on the right-hand side there, where he ran the slip sweep, and he got a 50% increase in production on his land seismic crews in the Oman, which was fantastic. So the top right there on that vertical axis, if you can't see it, is about 220 vibrator points, shot points per hour, which is pretty good. So then we have to jump to marine, because an interesting thing happened about 2002. We did some PRM, permanent reservoir monitoring, and putting cables into the seabed, using all the offsets, all the azimuths, greatly improved illumination therefore, and by doing surveys every 6 months or so, or a year, you could produce a movie of what was happening in the reservoir. Changes in saturation, changes in pressure, changes in subsidence in the reservoir. And it was absolutely eye-watering to see these things happen. So that's why I had to leapfrog there into marine for a little while, because that shows us what you can do with permanent reservoir monitoring. And then a bit of a surprise, because FAS, full azimuth recording in marine, took us a bit by surprise in 2005, because good old BP recorded a 3D seismic survey, not just once, but actually 6 times in 6 different directions, 6 different azimuths. And that had the most amazing, again, an eye-watering display of 6 azimuths versus a single azimuth. And of course, we all knew that we'd like to populate the azimuth domain, but this particular project, research project at the time, really works up to the virtues of doing that. In this particular case, it was refracted multiples, but there are all sorts of other reasons why we should be populating the azimuth domain, as well as the offset and the XY domain, etc. In fact, this chart here, which was produced in this forum just a month ago by Chris Page, shows other good reason why you should be recording all the azimuth domain, because if you have a complex subsurface, and do we ever not have, then you can predict with some simple modeling and scattering of energy. If you take the middle panel there with a limited range of azimuths, you end up with some places there in the subsurface which are not even imaged properly, or maybe not even illuminated at all. And it's when you go to full azimuth that you get that improvement. So that's what we should be doing, really. So that was a wake-up call. But I have to say now that marine seismic is up against a brick wall at the moment, because PRM, permanent reservoir monitoring, and FAS, full azimuth recording, which you do nowadays with multiple boats to try and do it more cheaply, it's still far too expensive, and to get the money to do that is actually very difficult. But we'd really like to do well-sampled marine surveys, but they're up against the brick wall. And until permanent reservoir monitoring, because that's really the way to do it, becomes cheap enough, then I guess we stay on that brick wall for the moment. So let's jump back to land. And okay, now the slip sweep is in operation, and this is a very interesting chart from Saudi Aramco, who do more land surveys than anybody else. And if they plot all their the vertical axis there is vibrator points per day, the sort of rate of progress, and draw an average line through there. The expectation now is about 2,500 shot points a day. So that's what I would call 21st century land expectation. That's sort of current state of the art, if you like, about a couple of years ago. So that's about where we are. Now, just bring that chart back up again and focus on it for a second, and look at the just look at that, because I'm going to redraw. I'm going to position that chart in a different set of axes, expanded set of axes. So there's that same chart, and on the left axis I've got the shot points per day again. On the right axis I've got vibrator points per hour. And an immensely interesting thing happened in the last couple of years, because all of a sudden this happened, which was just mind-boggling, really. A couple of new technologies emerged, not complicated, actually very simple technologies. ISS, independent simultaneous sweeping with vibrators, DSS, distance separated simultaneous sweeping. Quite simple technologies with a bit of technical risk, but manageable. And you can see that all of a sudden these production rates in the desert environment are just enormously increased. And the VPs per hour there, I mean, it's almost an order of magnitude higher than the previous expectation. A lot of that's in good terrain, but not all of it. The average VPs per hour is sitting down here a little bit, but it's still a factor of 2 or 3 above the expectation. And what's actually happening here is that the actual vibrator, the source rates are still high, but what they end up doing is they're waiting for the receiver spread to be rolled through and move forward. So in the difficult terrain, it's that's holding them back. So that suggests actually that we should be looking again at these sort of technologies. This is a photograph actually from the at-scale experiment of the independent simultaneous sweeping, which Dave Howe and BP got going, invented actually, and got going in Algeria in 2007, 2008. So there's the what I'd call now the goalposts have changed. The expectation, which had been about 2,500, is now up at 10,000 VPs per day. So that slide, we have to rethink our land operations accordingly. Now, of course, there is some technical risk there in doing these things, because land is a tricky environment, irrespective of how fine you make your sampling rates, and these are channels that are just a few centimeters apart. There's a tremendous amount of seismic noise and so on. So there is some technical risk, but actually the ISS system and the DS3 system, they're gaining 500-fold, between 500 and 1,500-fold of data. So actually the data quality has actually been superb. So just to put that into perspective for you, there's the chart I showed you before with the desert cost, unit cost, sitting there. Well, what's happened now with these new technologies is the desert unit cost has dropped to actually below the cost of marine seismic. So it shouldn't take very long before the oil company mindset changes, and they're saying, well, you have to justify why you're not doing a 3D survey in your desert. Now, of course, deserts are deserts, and it doesn't necessarily address, I haven't addressed how you might cope with mountain costs of 3D. But actually in BP we did try that. We had a joint collaboration effort with Sercel and with Western Geophysical to produce some much lighter equipment, and actually that made a measurable difference, something like 30 to 40% cost reduction in the high mountain area with the light kit. And that's in terrain that looks a bit like that. I mean, this is difficult territory. It's about the one extreme of the seismic business. And there you can see the result of that collaboration between BP and Western. I'm not sure which logo I was supposed to wear at the time, but anyway, there's the state of the art as it was, and there was the new device which Sercel produced. And this was done also with Western Geophysical. Western were the other really high quality seismic contractor at the time. You've got it. So of course, in my mind was how can we maybe reduce all the weight and the fact that we have to string these cables around. And it's not clear to me really that going to these autonomous units is going to be hugely better in the early days of these units, but certainly with the old Amoco SGR we'd have to use hundreds and thousands of them, and it wouldn't have been practical. But the developments are going apace now, and these machines are becoming really, really viable. That's not quite what I had in mind. I mean, what I had in mind was more like this. But you have these much, much smaller, lighter units almost everywhere. But we're not quite there yet. The American military has a solution to that. But these things weigh a couple of kilos, so if you collected one on its way down, you'd be the end of you. So it wouldn't be the way to do it. Anyway, what's happening? Well, outside the box, actually, companies like Hewlett-Packard have been developing bits of equipment. They have an initiative called the Central Nervous System for the Earth, which is not just seismic, it's all sorts of other things, temperatures and sounds and so on. Trillion sensor network. So these are things going on in Silicon Valley that you can't ignore, and these are the sort of size of the chips, about sort of aspirin size. I have one or two with me if any of you have got a headache. And they're very high quality, high specification devices. If you look at what's going on with the guys who are developing this, Peter Hartwell of HP Laboratories, I mean, these guys have their conventions just as we geophysicists do, and the one coming up in their expo, he's giving one of their keynote talks on this MEMS microengineering architecture to get the ultra-sensitive, low-cost wireless sensors by mission critical. In this case, actually, it's seismic. So they've teamed up with Shell, who are the first nervous system, if you like, partner in this venture. And they've also teamed up. Shell have also got PGS on board, because PGS have been doing great things with fiber optic sensors, and hopefully the combination of these will see a step change in land seismic. If I look at the kind of the data rate on land equipment, bits per second, it's a logarithmic scale. It's a bit like Moore's law, it's kind of doubling every short space of time. And I'm just picking a few of these examples on the way up there. And there's no reason why that shouldn't carry on up. And of course, if you have autonomous units or fiber optic coupling, there's virtually no limit to that graph these days. So, what we'll probably see, maybe by 2012, I don't know whether it's late this year, early next year, or whether it'll have teething troubles or whether it won't, Not all systems get out into the field without their teething troubles. But anyway, they will certainly have much more channels. It'll be much more node-like, autonomous equipment-like. There'll be the extensive use of fibres. There'll be much lighter weight, and there'll be probably permanent systems on land earlier. It'll be cheaper and earlier than they'll be in marine. So it's an interesting state of the art, really, where the land seismic is at. And my goodness, the opportunities are enormous, because if I plot the number of rigs operating, this is the Baker Hughes database of last month. You can see the number of land rigs operating is there, the number of offshore operating rigs is there. Well, how many of these land rigs are drilling on 3D seismic? The answer is not a lot, and the opportunities there are therefore enormous. So, I think that's where we are. It's actually been a really exciting last few years for seismic. It's been very vibrant. Technology's been really moving forward. And the marine technology probably will eventually, with PRM, when it gets cheaper. There's a workshop in Trondheim at the end of this month and early March to discuss that. I hope you come along. And they're pretty exciting times, but we'll still have some problematic terrains, and it won't go down to a few dollars a square kilometre overnight. Anyway, thanks very much for your attention.
Okay, any questions? Who do you think is going to lead this? I mean, obviously, HP stands a very good chance of becoming a wholly owned subsidiary of Schlumberger if they invent anything reasonable. But who's actually? Because I was curious that Shell had obviously decided to take the lead, based on what we heard last time.
Yeah. And now that PGS are on board, it gives me a much warmer feeling, because if just Shell and HP were to go into the field with something, it could be a bit of a learning curve. I mean, I can think of other examples of instruments that have gone into the field with insufficient field preparation, and it can take 10 years for a new system to, once it's deployed, to actually get to be working. Western Geophysical used to have a gentleman called Ray Grimes. I hope he's still working for them, because he's a wonderful guy. He was the guy who would check, who would field test all the equipment before their crews would take it to the field. And what I hope this system has is a Ray Grimes to nurse it into the field. And if that's the case, then I would say possibly PGS would be moving back into land again. But that's pure speculation.
Yeah, please.
Is the cost for the desert work? I'm a minerals exploration geologist, so I'm completely ignorant. The cost for the desert work seems to be minuscule compared to other areas. Would that bias junior explorers to work in the desert? They get more bang for their buck, or whatever the correct phrase would be now?
Yeah, I can give you an example. The place to go would be the Orange Free State, where it's nice open territory, and you could run your vibro-size units around and get seismic, 3D seismic, high-quality 3D seismic for less than the cost of marine. So that's the kind of place where I would envisage it being used, and it would probably completely redevelop that market for minerals exploration, because, of course, in the Orange Free State it's gold, and they have pretty similar problems to us oil and gas explorers. You've got fault blocks, and you need to know where these fault edges are, because once you put in your mining operation, it's just obviously impossible to make money if you come up against a fault every so often. So same with coal exploration. So yeah, I would say that it would revitalize a lot of these minerals exploration. Does that answer your question?
No, over there, Carl.
John.
Yes, Ian. You didn't say much about wireless. My understanding is that the future may well be wireless, given that a lot of the time is spent laying cables and a lot of the weight of the kit is in the cables. Is that the way it's going to go?
I expect what will happen, John, is that the local autonomous units will be wireless, and they will all form a network, and occasionally you'll have a fibre optic connecting, but that's pure speculation at the moment in terms of this system I've just shown you about.
But just to be clear then, because I mean, some of those early wireless systems were quite heavy.
Oh yeah.
The batteries died relatively quickly, and people are progressing. But you've not yet seen something where you look at it and say, this is it?
Yes, already you can have these autonomous units in which the batteries will last for weeks. So I think wireless is in there. The battery, of course, if you're talking about an autonomous unit that will run for several weeks, it's a bit more like a hand grenade size rather than an aspirin. But that's pretty good still.
Okay, one more.
Hang on. I was going to say, just in the desert, you could have solar-powered batteries as well, maybe permanent.
Certainly you could, yeah. In fact, some of the early, some of the existing land units, many of them use solar power to help keep the batteries topped up. But power is a problem on existing systems, by which I mean systems that are up to 10 years old or so.
Okay, anybody else? Okay, thank you, Ian. You going to take that with you, or leave it there?
All right, mine. Whichever Gary wants.
Okay, right. Next we have. Thank you. Next we